Hi guys, welcome back. So in the last tutorial we learned how to simplify SURDS using those two different techniques, and today we're going to be applying what we have learned in exercise 1.02 of the New Century Maths Advanced textbook. Now today we're going to be going through the last column of questions 1, 2 and 3. Okay, so let's get stuck into it. Question 1, simplify each expression. Remember from our last video we learnt rule 1, which stated that any number rooted and then squared is the same thing as that number under the root. So I'm probably, when I see this square number at the top, looking to try and use this rule. So straight away I can see that I can probably just turn that into a 10, but we have this 5 out the front. So how am I going to deal with that? Now the solution that I'm going to do will involve turning this whole thing into one big surd. So in order to do that, we make use of rule 2. So remember, rule 2 was that if any number can be denoted like this, so two factors, those factors can be split into two parts. Okay, so currently we have it in this form, and we want to get it in this form so that we can just get the answer as x, y. So we can see that we have our y here, which is our root 10. So that's already in its root form. But this 5 is not quite in its root form. So how are we going to do that? So 5, to get it into its root form, we're going to want to square 5. So 5 times 5 is 25. So that means that root 25 is the same thing as 5. So we now can say that our x over here is root 25. So that just means 5. And we also have our y, which is going to be root 10. So when we have two surds like this, we can multiply them straight across and we end up getting root 250. Now notice that this is a multiply, not a plus. If we have a plus, we're not allowed to mix two different surds, but right now it's a multiply, so it's okay. So this whole thing inside the brackets, we can just say is root 250 now. So we've got root 250 inside the bracket, but we also need to make sure that we remember this square out here. So this is the same thing that we've got. And remember, now we can use rule 1 straight away. So if we have any number rooted and then squared, it's that number underneath the bracket. So as we can see, we are rooted and we are squared. So we can just use 250 for our answer there. Okay, so let's go on to question H. Now we can see straight away that this is a little bit different. It's similar, but we have a minus sign out the front. So what does that mean? Now, to make this easier for us, so that we can use a similar method to what we used in the first one, I'm going to rewrite this as minus 1. So this is just the inside the bracket bits, remember, times 5 times root 2. So using the same method that we had before, we can say that this is the same thing as root 25, because 5 times 5 is 25. Now minus 1 is a little bit tricky because it's going to be the same thing as if we just did normal 1. So 1 times 1 equals 1, but what does minus 1 times minus 1 equal? Also 1. So we can write this also as 1. Now this one's already in surd form, so then we are left with this form here, which is root 1 times root 5 times root 2. So we can then say, using the root form of all of these numbers, that we have root 1 times root 25, and then this one's already in root form, times root 2. And timesing all these across, we can see that 1 times 25 times 2 equals 50. So that root 50 is the same as inside this bracket here. Okay, so taking that root 50 now, when we figured that out to be the inside of the brackets, but we need to do the outside of the brackets as well. So again, we're going to use the same as we did the first time and say that these two cancel out because it's a square root and a square. So therefore they're opposites, and this just equals 50. Okay, so question 2 now. Now remember, the reason why these look funny is because we're doing the last row of each question. So let's get started with question E. So simplify each surd. Now I can see, because this is an ugly number, I'm going to need to simplify it, most likely using my rule 2. So finding factors of 700, which means two numbers that times together to equal 700, and then it'll allow me to rewrite it. Ideally, I'm going to be looking for a number that's squared so it can look nice and clean. Now straight away I see these 2 zeros on the end, so that means 100 is going to be a factor. So 100 times root 7. Now remember, that's using our rule 2. So I can simplify this even further, because root 100 is the same as 10. Now this 7 here, that's a prime number. It doesn't have any factors, so we can't put it down any further. So that's going to stay as 7. So we have 10 root 7 as our simplified form there. Question J now, let's go on to J. So root 63. So now this time I don't have quite an obvious factor here, and it's not even, so I can't simplify it down by going through with 2. So I'm going to try 9. So remember, 9 is a square number because it's 3 times 3. So if I put 63 divided by 9 in my calculator, it does go in. So that's 9 root 9 times root 7 is the same thing as root 63. Now what's root 9? That's right, it's 3. And again, we've got this same thing, this prime number, so we can't simplify it down any further. So that there is going to stay as 3 root 7. Okay, on to question O here. So we've got root 32. So root 32, I'm looking for a nice, hopefully square number that will fit into it. And I'm going to try putting in a 2 first, just so I can see whether it fits in. So I can go divide it by 2 in my calculator, and I will get 16. So 16 times 2 is 32, so we can write this in our root form. Now that works out nicely, because even though root 2 is a surd, a prime number, so we can't simplify it down anymore, we have this root 16, which we also know as 4. So we can write this whole thing now as 4 root 2. So that's our answer for O. Okay, so our last one now, we've got 512. Now again, it doesn't look like the easiest one for us to go and do, but I'm going to go straight away and divide this by 2 to hopefully get it into a little bit of a nicer number. So we got root 2, because I can see that it's even, so I know that 2 is going to go in. 512 divided by 2 in the calculator. So let's put that in now. We get root 256. Now, if you're not sure whether this is a proper root or not of a bigger number that we're not as familiar with, so usually we know up to our 12th root, 144. After that, we're not too sure. So you can go ahead and test that in your calculator, pressing your root button and then writing in 256, and you will see that this is the same thing as 16. So in other words, 16 times 16 is 256. So we can rewrite this 512 as 16 root 2. We're going on to question 3, again simplifying each expression, but we can see here that they've given us a pretty ugly form for us to work with. Okay, so let's get into question E. So for question E, we can see that the first thing I'm going to do is I'm going to want to simplify this number at the top. So usually you always want to simplify before you go and do any other steps. So 243, I'm probably going to try and find a square number that fits into that one. Now, it's not a very nice number, so usually when it ends in a 3, I would try and divide it by 9, because because that's 3 times 3, a square number. So 243 divided by 9 gives me 27. So that's root 9 times root 27. Okay, and we know that that is the same thing as 3 root 27. Now, can we do better than that? I think we can, because 27, that should sound familiar in our times tables. That's the same thing as 9 3s. So root 9 times root 3. So I've taken out root 9 again here, and that gives me 3 times root 3. So root 3, does that have any squares that go into it? No, because it's a prime number, so we're going to have to leave that how it is. So what have we got here? We have 9 root 3. Okay, so now that we've got this in our most simplified form on the top, our bottom can't really be simplified anymore, we can go ahead and look at the broader picture. So we can see here that we've got 9 root 3 over 9. So if we were to take apart this into 9 over 9 times root 3 over 1, because remember, if we times this all together, it's the same thing as this. So 9 over 9, what's that the same as? So any number over itself is the same as 1, and you can test that in your calculator by going 9 divided by 9. So this ends up being 1 times root 3 over 1. And if we only have one lot of root 3 over 1, what does that mean? So root 3 over 1, same thing as what? Root 3, because these ones are going to cancel out. Okay, so we're going to be doing J now. Now this one, again, has got a bit of a funny number out the front, so it's just in a bit of a different form to this first one. So we could write it out in the same way we did before, because remember, a half times root 72, now the whole number, we can write it over 1, would then just be the same thing as root 72 on 2. So then it would be in the same form as we had earlier. Okay, now I can see that my denominator doesn't really need to be simplified very much, so I'm going to focus on this numerator at the top. So again, I'm going to be thinking of a square number that goes into 72. Now 72, I can cheat straight away and take out a 2 because it's an even number to see if it gets any easier. So root 2 times, so you want to do 72 divided by 2 to get the factor. And you will see that that is 36. So as you can see, they're being pretty nice to us in the book, because we know that root 36 is what? That's right, it's 6, because 6 times 6 equals 36. So taking these two together now, we can see that we have 6 and a root 2. So we can put these together in our nice form as 6 root 2. So now we're going to replace our numerator with our simplified form. Okay, so I have my 6 root 2 now replaced on the top over 2. So I can see now that is in its simplest form. This is in its simplest form. So I can now start to look at this as a whole. So again, if I were to rewrite this the same way as before, we can split it like this. So 6 over 2 times root 2 over 1. Okay, now can we simplify these anymore? That is in its fully simplified form. What about this? So 6 over 2. So that's the same thing as saying 6 divided by 2, which is 3. So we have our 3 over 1, or just simply 3. So if we go 3 over 1, root 2 over 1. Remember, over 1 just means it's a whole number, so we can times straight across, and we end up with root 3 over 2 over 1. So what's root 3 over 2 over 1? Any number divided by 1 is the same thing. So root 3 over 2. So our last question now, question O. So for O, we have a nice simple form. We don't need to worry about getting it into that same thing as we did before, but we still have an ugly root 52 on top. So we're going to try and simplify our numerator first. Our denominator doesn't need to be simplified, I can see, because it's a whole number. But let's do this 52. So again, 52, it's not a square number, but I can take out 2 because it's even. Let's see if that makes it any easier. So root 2 times, so then you're going to put 52 divided by 2 in your calculator, and you see that that's root 26. Oh, not so helpful. Okay, so we're going to take out 2 again. We've got root 2 times root 2 times, now it's 26 divided by 2. Root 13. Okay, now 13. Now, we should know that 13 is a prime number, so we can't divide. There's no two numbers apart from 13 and 1 that divide to get 13. So that there is its simplest form. But we've now got a whole lot of surds. So what do we do here? Now, I'm going to need you to remember what your rule 1 was. So we've got 2 root 13, and because this 13 is in its simplest form, 2 can't be going down anymore. We can then make sure that is our overall numerator. Over 6, we're going to do our same thing, split it up into our surd, which is root 13 over 1, or just root 13, and then our whole numbers, which are 2 over 6. So that's now 1/3, and if we use our multiplication of fractions, we can say 1 times root 13 is going to be root 13. So that's the top. And then for our bottom, we have now 3 times 1. What's that? 3. So this here, root 13 over 3, is our simplest form.